everyone, I am Dr. Kusumita Kundu, Assistant Professor of Chemistry in SPST. Today's topic is reaction mechanism. Okay. So there are three types of reaction basically. First one is addition reaction. Second one is substitution reaction. And the third one is elimination reaction. Now we will first discuss about the addition reaction. Okay. So what happens in addition reaction? Let's say there is a alkene. There is a alkene and it is in presence of any hydrogen halide. In presence of any hydrogen halide, what it will do? This unsaturation will attack the hydrogen atom and it can form two different carbocations. Okay. What are those? So this can be one carbocation and another one can be CH3, CH2, CH2 plus. Okay. So this is 2 degree carbocation, this is 2 degree carbocation and this is 1 degree carbocation. As we know that 2 degree carbocation is more stable compared to 1 degree and it is more substituted. So what will happen? Now if a nucleophile attacks in this site, so it will produce more substituted alcohol. This 2 degree carbocation will produce more substituted alcohol, while the less stable carbocation will produce less substituted alcohol. Okay, it will produce less substituted alcohol. So the possibility of the production of this molecule is very low. So this will be the minor product and this will be the major product. Okay, so this whole reaction is known as Markovnikov addition reaction. Now while we are studying about Markovnikov addition, we have to know about the anti-Markovnikov. Anti-Markovnikov addition always gives less substituted alcohols. Okay, and anti-Markovnikov takes place only in presence of HBr in any kind of peroxide. It is hydrogen peroxide, it may be alkyl peroxide and all. HBr in presence of hydrogen peroxide or alkyl peroxide will give anti-Markovnikov addition. Okay. Next we will be coming to the substitution reaction. So in case of substitution reaction, what happens? The leaving group is substituted by another nucleophile. Okay. Now this substitution reaction basically mainly follows nuclear substitution reaction. There are two types of nuclear substitution reaction. One is SN1 and another one is SN2. SN1 and SN2. In SN1, there are two steps which follows the SN1. First one is formation of carbocation. And the second step is attack of nucleophiles. These are the two steps involved SN1 reaction. While in SN2 there are only one step. That means in SN2 the attack of the carbocation and the departure of the leaving group both is happening at the very same time. Okay, it is a one-step reaction. One-step reaction. Now, in case of SN1, as we are saying that the first step is the formation of carbocation, and in case of SN1, this is the most important step, and this is the rate determining step. Okay. So rate will be in case of SN1, K, that is rate constant, into concentration of the substrate. In case of SN1, this 1 represent, it is unimolecular. Why it is unimolecular? Because the rate of this SN1 reaction is dependent only on the concentration of the substrate. Okay. While in case of SN2, it is bimolecular. Substitution nucleophilic bimolecular. Okay. So rate is K, rate constant, into concentration of the substrate into concentration of the nucleophile. Because in case of SN2, the attack of the nucleophiles and the departure of the leaving group is happening at the very same time. Okay. Now, what happens in case of SN1? Formation of carbocation is the most important step or rate determining step. Now, let's say this is an alkyl halide. Okay. So first step will be departure of the leaving group, thereby giving us a carbocation. Okay. Now what happens when the nucleophile is attacking to the electron deficient site? It can attack from this side or it can attack from this side. So both side attack is possible. That is why in the product, in SN1 reaction, it will give racemization. Okay, so it will give racemization. But in case of SN2, what happens? Let's say this is H, 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 X. In SN2, what is happening? Nucleophilic is attacking the carbon deficient, electron deficient site, and departure of leaving group is happening at the same time. So this is nucleophile, hydrogen, hydrogen, hydrogen. So if the substrate is, if we say that it is in the form of D, the product will be in the form of L. Okay. So in case of SN2, this is SN2. In case of SN2, 100% inversion or complete inversion is happening. Or complete inversion is happening. Okay. In case of SN1, racemization is there. But in case of SN2, 100% inversion is happening. Okay. This is also known as Walden inversion. This is also known as Walden inversion. Here, as you can see, in case of SN1, carbocation formation is the most important and the rate determining step. So the stability of the carbocation will increase the rate of SN1 reaction. That means the most suitable substrate for SN1 is 3-degree alkyl halide, 3-degree alkyl halide, greater than 2-degree alkyl halide, greater than 1-degree alkyl halide. Right? So 3-degree alkyl halide would be the most suitable substrate for SN1. While in SN2, the attack of nucleophile and the departure of leaving group is happening at the same time. So if there is a bulky group present there, so the nucleophile will face a steric hindrance, so rate will be dropped, rate will be decreasing. So in case of SN2, the most suitable substrate is 1-degree alkyl halide. The most suitable substrate is 1-degree alkyl halide. Then 2-degree, then 3-degree. Okay. So this was SN1 and SN2 reaction. That was for substitution reaction. And the last one is elimination reaction. Last one is elimination reaction. In case of elimination reaction, there are basically two types. One is E1, another one is E2. This E1 reaction is basically very similar to SN1 reaction. Okay, and this E2 is very similar to this SN2 reaction mechanism. In case of E1 also follows two steps. First step is formation of carbocation. And the step is attack of base. Attack of base. Okay. While in case of E2, it is basically a single step reaction, and here the attack of base and departure of leaving group is happening at the same time. Okay, is happening at the same time. Okay, so this was the 3 types of reaction mechanisms. Now we will discuss about the name of this reaction based on these 3 mechanisms in our next video. Okay, thank you so much. Thank you for watching.